Hello and welcome to the directions video for the Ohm's Law lab. All right, so I'm going to be going over the procedure part of this lab and showing you the steps. Okay, so I have a printout of the procedure here and I'm looking at step 1. I want to make some preliminary measurements. So we're going to measure the voltage across a battery. All right, we'll go ahead and start with this battery here. Then I'm also going to measure the current through that battery. All right, and that's going to give me most of what I need. It says the third measurement is to measure the diameter of the paperclip. I won't include that in the video. You're welcome to look up that information or make a measurement yourself. Okay? All right. So let's go ahead and measure the voltage across my battery. So I already have my multimeter set up here to measure battery voltage. Notice that I have the plugs in voltmeter mode, so essentially with a very high resistance between the negative and positive terminal. All right, so let's go ahead and measure that voltage. All right, so you know things are working if you get a reasonable number here. All right, so I'm getting about 1.37. Let's see, can you see the reading? Yeah, I don't know if you can make it out. I'm gonna put it over here, see if that helps. All right, and I'm also getting a negative reading. If I switch the polarity of the probes, then I can go ahead and get a positive reading. And it's a good sign on a battery like this that I'm getting about 1.37. Okay. All right. So with that out of the way, I'm going to measure the current through the battery. And to do this, I found a good way to do it is to hold this paper in place with the paper clip so that it's kind of being held together like a spring. Okay, so first let's kind of attach the paper clip. Notice when I do this, in order for the paper clip to not heat up, I'm actually not connecting it to the metal end of the positive terminal of the battery. Some batteries will actually show metal here, but it's not actually a conducting part of the battery. The paper clip would have to touch this metal nub in order to complete the circuit and short circuit the battery. Okay, so let's set up like that. That looks good. All right, and yep. Definitely no connection. So this is nice because I don't have to worry too much about the paper getting in the way. All right. So let's go ahead and see if we get a good measurement this way, and then I'll show an alternative way of measuring the current. Okay. But first I have to switch my settings on my multimeter. Okay. All right. Actually, from now on, I'm going to kind of hold it up like that so you can see it. Okay. But I need to switch my settings. All right. So the first thing I'm going to do is I'm going to move my plug. All right, I'm gonna move this over to DC 10 amp, and then I'm gonna switch it to DC 10 amp. So this would be the appropriate setting on this particular model multimeter for measuring something in the range of 1 to 10 amps, where we want a very low internal resistance on the multimeter, and we're going to measure that current through the multimeter. So in other words, we're gonna put the multimeter in series with our other circuit elements. In this case, the resistor and the voltage source. Okay, so let's go ahead, and the resistor, of course, being the wire. Okay, so I'm just going to complete this circuit as best I can. All right, see if this works out. All right, very good. Okay, so I'm going to hold this up. All right, so trying to get good contact here. I'm getting in the range of 4 to 5 amps. I'm gonna try to hold it down over here so I can get a good, there we go, much better. So it looks like it's definitely gonna be in the low 4s. It's slipping on me, smallest bit, there, nice. Now this one's slipping. Yeah, so it's always gonna vary like this, but you can see it's very between 4 and 5. If I have a firm connection, it seems to be actually staying more around 5. So you could estimate that 5.2 amps. I think that's fine. And since you're just going to take that one reading, that one estimate, and use it for all your other calculations. So whatever inherent error there is in that measurement of current, you're just going to go with it. All right, and that's kind of built into the lab. But we do have a good estimate. In this case, I would estimate 5.2 based on what I just did. Now the paper is mentioned because alternatively, we could have had the paper clip set up in such a way where it was making a conductor on conductor contact with the positive terminal there, as you can see, actually touching. And then we would use some paper to stop the flow of current here. So I'd wedge the paper in between, like so. All right, show you that. And this is good on certain models of batteries, especially those where it's harder to not touch the metal on the positive end. Okay, all right. So I lost my paper there, but you get the idea. You'd wedge it in place, okay? Now, when I was doing that just now, I immediately started to feel the paperclip heat up because I had completed the circuit for a second and it was working quite well. So let's go ahead and move on to that part of the lab, all right? Now, what you'd probably want to do ahead of time is pre-measure some points on your paperclip and mark them out. I was just kind of experimenting with that here and started marking some green points there. You can see it's not quite focusing, but you can see. All right, and you want to maybe measure those in 1 millimeter increments or 2 millimeter increments. Make sure you have 10 of them, and those are going to be your 10 known distances. And then you probably just hold one of your probes at one end of all those measurements, and then move the other step by step, getting longer and longer distance between the two probes. Okay. All right, well, let's complete our circuit and have our wires start to get hot. All right. Sure can feel it. Okay, let's see. Yep. Wants to pop off, of course. There we go. All right, let's see if it's working. All right, I probably should have done this ahead of time, but I'm just going to switch over now, back to volt mode. And I only say ahead of time so that I wouldn't have to worry about doing the battery running out of power as I switch the mode. What I've done here is I switched over to DC volts, all right? And I'm measuring it in kind of that 2 volt increment. And this is based on the estimate of the voltage I expect. Let's go ahead and do a distance here. Oh, I lost it. All right. So I'm just kind of feeling this because it can get quite hot. Go ahead and switch paper clips because that one is so hot. All right, you just want to wait for it to cool off. All right, so let's try this. Okay, I think that's making contact. Let's get a measurement here. All right, excellent. So see I had it here. Let's get one more I can hold it down as and roll around. All right, there. See that? 172 millivolts. And these measurements will vary much less than your current measurement. Look at that. There's usually a creep like that, where it will gradually kind of creep down, or creep up. But here you see, like, right, it's staying right in that low 80s, right? And there's some motion there, right? It's obviously because I'm kind of moving my finger around. But if I make it shorter, significantly shorter, look, that voltage difference goes down significantly. Here we have about 1/10 of a volt. So 0.1, because right now it's in volt mode. So these aren't millivolts or anything. These are in actual volts, all right? And obviously a much shorter distance along the wire is only there 20 millivolts, right? Looks good, right? Okay, so because we went from 1/10 down to about a 20th, okay? Okay, or a 50th. So that's the idea. And you can see that those volt measurements work quite well as long as you have your multimeter in the mode where you have high internal resistance or just voltage mode, and you set it probably on like the 1 volt measurement, or see, I didn't have it in millivolts, I didn't have it in 20 or hundreds of volts. I was kind of measuring right there at 2 volt accuracy, 2 volt range. Okay, all right, so that's most of the lab, right? Again, you're gonna be taking multiple measurements of those voltages, those voltage measurements at different lengths. This will be a big part of the lab. Okay, I have a very hot wire now. All right, battery itself also hot. So let's go ahead and put it on the ice just to watch that it does indeed start to melt the ice nicely. All right, quite hot. Okay, let's get it. Oh, I lost my connection. Okay. All right, so you've seen most of the content of the lab at this point. If you want to stay for the last minute, you'll see the paperclip start to melt the ice to get some idea of what that looks like. Okay, so there we go. All right. Again, I'm just using the paper here to balance things. All right, I can hear or feel it getting nice and hot. And it's easier once it starts to melt into the ice. I'd probably want to take a weight measurement right now. Okay, see, it's already started melting into the ice. That will hold the ice in place. There we go. Okay. So right now the paperclip is delivering a lot of heat energy to that ice. The paperclip probably won't be as hot to the touch now. And it still is fairly hot, so it's not all of the energy is getting delivered to the ice, but a significant amount. If you take a look near the ice, you can really see it sort of evaporating or boiling in contact with the metal, and the metal sinking into the ice, and it's greatly speeding up the process. So you would just want to wait this out at this point. You would have already started the clock kind of from the minute that this particular piece of ice started melting. And it's good to, again, probably take that weight measurement as soon as possible. I would use a kitchen scale, right, and get an idea of how much solid ice there was once you started melting it. Okay? You can see now that the metal has sunk almost completely down into the ice. So again, that's the majority of the lab. Multimeter in 2 different modes to measure current and voltage respectively. Your voltage measurements are going to be the only measurements that you need to repeat and are the majority of the actual measurement part of the lab. All right. Well, thank you so much for watching this directions video. I hope it's helped make sense of what you're doing with this interesting at-home lab. Bye for now.